Hello everybody, my name is Miss Oliveras and today we're going to continue with our geometry class. Today's topic is going to be measuring angles. At the end of this lesson, you will be able to recognize angles as geometric shapes that are formed whenever two rays share a common endpoint and understand the concepts of angle measurement. You will be able to measure angles in a whole number degrees using a protractor. You're going to be able to sketch angles as specified measurements and know precise definition of an angle. Our vocabulary words are degrees, protractor, right angle, acute angle, obtuse angle, and I would also include there straight angle. I just forgot to write it there, but the other one will be straight angle. So an angle is just a figure that is formed by two non-collinear rays that have a common endpoint. And when I say non-collinear, I'm going to try to draw it here. A collinear point at the ray will be something like this. One is going this way, and the other one will be going in the same direction, and that will make them collinear. Now, non-collinear, that means that they are not in the same exact line. So again, I will have a ray. I'm going to have an endpoint. Then I also going to have another ray that is not in the same line. And that is what's going to form my angle. And that angle is going to be the distance between those two rays. Let's continue. The common endpoint is called a vertex. This part here is called a vertex. And the two rays that makes up an angle are called sides of an angle. Now, this will be a side and this will be the other side. There are several ways to name an angle. You can name it by using the vertex and a point from each side. Again, we can name it as one point, the vertex, and the other point. So for example, I can say this angle is called CBA, and this is the sign that we use to say that it's an angle. I can also call it ABC, or I can use the vertex only as the name of that angle. I can say this is going to be on my angle B, or using that vertex. Now I have to be very careful with this one because the only way that I can do this is if that vertex it is not being shared by any other angle. So that is very, very important. If this continues here making other types of angles or other types of figures, that I cannot use that name for my angle. I can use that vertex as my name. I can also use a number to name them. I can say this is angle number 1, number 2, number 3. It all depends. I can just number them. Angles are measured in units called degrees, and the symbol for that degree is that little circle right there in that suffix on the right top of a number. So the angle measure postulate says that for every angle, there's a unique positive number between 0 and 180, called the degree measure of an angle. And that just means if I have two rays, 1 and 2, that angle that forms between them is going to be more than 0, or just between that 0 and 180. The protractor postulates describe the relationship between angles measures and numbers. On a plane given, AB as my ray, and a number T, that is this, and we don't know which one it is, I just put them there, between 0 and 180, there is exactly one ray with endpoint A extending on each side AB, such as the degree measures of an angle formed is T. Okay, so I'm just going to simplify this for you, and that the only thing that it says that there is that if you have a ray, and I'm going to try to draw my own ray here. Sorry for that. It's supposed to be straight, so just imagine that it's straight. If I have a ray called A, B, I have nothing else there. All it says that if I do another ray next to it sharing that endpoint A, I'm gonna do one in another color. In each of the other two ways of that ray, that is going to form angles between those two. That is what my protractor postulate says. That is all it says. That means I'm going to have my original ray, and if I throw again another ray, doesn't matter which direction, that distance between those two is going to make an angle. That is all it says. A protractor can be used to approximate the measurements of an angle. And I don't know if you guys have ever seen a protractor, but it's something like a ruler, but instead of being flat, it's curved, and I'm going to show you that one in a minute. At least I'm going to show you the picture of one of those. And you have to see it like if you were measuring a segment with a ruler, instead of measuring units that are in a number line, we would just use it to count the distance between one ray and the other one. And because we are measuring angles, that's why the protractor looks like a half moon, because it's going to be measuring from one distance from one ray to the other one. And this is how you would use it. You will place the notch of the protractor on the vertex of that angle, and then you will place the edge of that protractor along one of the sides of those rays, and then you will read the distance between those two in degrees. Now, there are a few types of angles, and I think you guys have seen this before. If not, we're just going to review it. There is what they call an acute angle, and that is an angle that the measure is greater than 0, but less than 90 degrees. That is what it is. An acute angle, again, is going to be the measurement. It's going to be greater than 0 degrees, but less than 90. Now, a right angle, the measurement is going to be exactly 90 degrees. An obtuse angle is going to be an angle that measures more than 90 degrees, but less than 180. In a straight angle, you will think that is a line, and you will be correct, but the distance between that ray and the opposite ray is going to be 180 degrees exactly. And this is what a protractor looks like. And if I were to do a measurement of any type of angle, I would just put my vertex in the middle here, and I will draw up my ray starting with 0. And let's think that is almost 0, so please bear with me. And then I'm going to measure the difference, the distance between those two. And I'm going to look for those numbers right here. I'm going to start with 0, then 10, 20, 30, and this angle is approximately 40 degrees of distance. So again, this angle here is going to be 40, that's a 0 there, degrees. That's the best I could draw it. Sorry for that. Now I'm going to tell you to find the measurements of each angle, then classify that angle between a obtuse, right, obtuse, sorry, acute, right, obtuse, and straight. So I just put my angle. One of them is at 0 and the other one is around, I would say like 45-degree-ish. And there we go. The measurement of my angle DCB. And remember that vertex has to be in the middle when you name that angle. Is around 45 degrees. And I'm just going to say around because this is a digital way to measure it. It is not exact, but if I were to measure it on paper, I can do an almost exact measurement. And that angle is going to measure less than 90 degrees, so it's going to be an acute angle. How about this one? This time I did not put my angle to this 0 right here, but if you look carefully to my protractor, you will see that we start from 0 to 180 and back again. So I can measure it from one ray to the other. Doesn't matter where I start the measurements. That means that the distance will always be the same. So if I put this one in 0, that means I'm going to look for the numbers above. And the measurement of this angle is between 130 and 140. So it's around 135. And if it's 135, then that angle is going to be an obtuse angle because it's going to be greater than 90 degrees, but not greater than 180. Now use a protractor on your notebook and try to draw each angle and then classify them. If you have the measurement of angle COB equals 15 degrees, try to draw it with your protractor and then try to classify it. Again, you can pause this video at this time and then check out the answers in the next slide. So I just put it here. I just measure from 0 to 15, and that will be a number between my 10 and my 20. And that is where I put that array. And because it measures less than a 90 degrees, it's going to be an acute angle. Acute angle, sorry. Now use a protractor to draw each angle, then classify the angle. Again, I have the measurement of an angle, HTR, equals 150 degrees. And my body is supposed to be like a little circle right here because it's 150 degrees. There we go. Again, I just used my protractor, and again, I'm going to look for a number after 140, before 160. There is my 150. And because it's more than because it's more than 90 degrees, this is going to be an obtuse angle. Now let's talk about angle addition postulate. And it's something like the addition of our segments, but instead we're talking about angles. And it says if T is the interior of the angle KLM, then the measure of angle KLM is equal to the sum of the measurements of the angle MLT and the angle TLK. Now let me simplify this for you. All that it says is that if I have an angle named KLM and suddenly I draw a ray in the middle of it or at any point at it called T or LT, that means that ray is going to form other angles between them. And the distance between the angle MLT or TLM is the same thing, plus the distance between KLT or TLK. Those two parts, those two partitions there, if I add them up, they're gonna give me the angle from KLM. That means this whole part here. So just think it as a pie. If I have a piece of pizza here and a piece of pizza there, and I add them up, they're gonna be the same measurements from one point to the other. So let's do a problem. Let's find the indicated angle measurements. Now it says that the measurement from R, TD, that will be from here. Sorry, I'm gonna look for, there we go. From here to here is 39 degrees. And I'm sorry I didn't put those degrees there. And it also says that the measurement between DTE from here to here is 56 degrees. What is the distance or the measurement from RTE? Again, I'm going to do it with another color. What is the measurement from here to here? Again, if we would just add them up, we have two parts and we add them together, we're gonna have our answer. We can pause this at this point, try to solve it on your notebook, and then check out the answer. So again, I'm just going to add them up. And the addition of this is going to be 95. So again, from here to here, I have 95 degrees. And if it's an angle greater than 90 degrees, what type of angle is it? If you set obtuse, you were correct. Amazing job. That means that is an angle greater than 90 degrees, but less than 180. Now try to find the indicated angle measurement. Again, they're telling you the measurements from the angle L, M, A. So you have that hole right here. So you have the distance between here to here, and that is 164 degrees. And they are telling you that GMA, that means from here to here, is 56. And sorry, but I'm using my touchpad right here. They are asking me for the measurement of angle LMG. What we do not know is everything that's from here to here. We do not know that measurement. So what do you have to do to get that measurement? So all that we would do here is just take the whole number, that will be the angle AML, and subtract what we know, that will be the angle AMG, and that way we can have the measurements of angle GML. Oh, LMG is the same thing, doesn't matter how you write it, you just need that vertex in the middle. The bisector of an angle is a ray with its endpoint at the vertex of that angle extended into the interior of that angle. The bisector separates the angle into two angles of equal measures. And the most important thing from that definition right there is that the bisector separates the angle into two equal measures. And I have to say this again, into equal measures. That means if I have an angle, for example, It's going to be an angle like this, sorry, like this. And then I have a bisector, sorry. Just the definition of bisector is going to mean that the distance between here to here and the distance between here to here are going to be the same. And I don't know if you remember, but every time I use that little line there, that means that that distance are equal to that distance. That means those are congruent angles. Now find the indicated angle measure if AC, that is our ray, is bisect the angle LAG. That means it's dividing that angle in the exact same middle. And I'm going to put them in two different colors, but they are going to be the same angles because it's being bisected. So it says that LAG, that means from here to here, is 64. That means from here to here is 64 degrees. What is going to be the distance here and here? Well, you just have to divide that 64 into two equal parts. And that will give me 64 divided into 2 is going to give me, sorry, into 2, it's going to be 32. And that means that the angle GAC is going to be 32 degrees and the angle CAL is going to be 32 degrees. Now try this one by yourselves. Find the indicated angle measurements. They're telling you that you have this ray right here that is called TG and is bisecting, and that word is very important because that just means that I am dividing my angle into two equal parts. And they are telling me that the measurement of the angle PTG equals 26. And you have to find the other angle here plus the distance between all of them. Again, PTD and GTD. So we already know that PTG is 26 degrees, and because it has a bisect, right? It means that they are congruent, they are the same angles, they are the same measurements. So that means that the angle DTG or GTD is the same thing, is going to measure also 26. And then we're going to add those angles up and we're going to have the measurements from DTP. And 26 plus 26 is going to be 52. Now it's homework time. And just like every other homework, I'm always going to give you around 10 exercises, never more than 10, to do at home. Go to your textbook, to your math book specifically, which one that has to have the logo that says Common Core Edition, and go to page 24 and 25 of that textbook and answer those exercises. Once you have answered them on your notebook, go to the Google form that is here below to that link. Click it and just add the answers of those exercises to it. Now, this form right here is going to be my evidence that you are doing your homework at home. So again, you must put those answers on that Google link. If you do not, that means your homework is incomplete and I cannot have evidence. I cannot double check that you are doing your job. So just fill those Google forms for me and send them my way. If you have any questions, you know where you can find me, you know my email, and see you on our next virtual class. Bye!